In today's video, we're going to be talking about the product to sum identities. But first, to get those identities developed, we go back to the sum and difference identities that we learned for sine and cosine in a previous video and in a previous section. So what we're going to start off with today is the quantity cosine of u minus v plus the cosine of u plus v. And we're going to expand both of those using the cosine difference and cosine sum formulas. So with that in mind, this cosine difference becomes the cosine of u times the cosine of v. Remember, with the cosine difference, you change it to a sum when expanding it, plus the sine of u times the sine of v. We're going to add to that then the cosine sum expanded, in which case we get the cosine of u times the cosine of v minus the sine of u times the sine of v. Now, if we consider those terms in that set of terms that we have, we'll notice that these two terms, one with the plus and one with the minus, are going to cancel each other out, in which case what we'll be left with is this cosine u cosine v as well as this one. And since those are also like terms, we can combine them together. So 2 cosine u times the cosine of v. Keep in mind, those are various or different ways to write this same quantity, which in this case was the sum of cosine u minus v and cosine u plus v. Now notice what's going on here. What we have is a product of two cosine functions. So the way that we're typically going to see this, rather than having a 2 on this side of the equation, we'll typically see it written as a 1/2 of this quantity. So what we'll see in this case is the cosine of u times the cosine of v will be equal to half of the cosine difference u minus v plus cosine sum u plus v. And that's one of the product to sum identities. Now, in this case, we've got a product of two cosines, and we can see that it equals the sum of these two cosines that we started with. So this is one of the product to sum identities. There are 4 product to sum identities in total, and what we're going to be looking at in the next little bit is how to develop those other 3 identities. So with that in mind, what happens then? Here we started with a sum. What if we had started with a difference? What would that produce? So if we consider this same cosine u minus v minus the cosine of u plus v, in which case that first expansion remains the same. But when we go to subtract these terms that are produced by the cosine of u plus v, we have to remember to subtract both terms. So here where we added this term and subtracted this term, the signs then switch. So this becomes a minus cosine u cosine v plus the sine of u times the sine of v. Normally this would have produced a minus, but because of this minus here, it's going to make it a plus when we distribute that negative. Okay, so now let's look and see what terms have canceled out. So here we've got a cosine u cosine v that's positive, and there one that's negative, which means those two will cancel out. As we look at the two sine quantities, we can see that they have the same terms, or the same factors in those terms. So in this case, the sine of u sine of v plus the sine of u sine of v. There again, we get a 2 sine of u sine of v. So we notice that in this case, in this difference of these two cosines produces a product of two sines. And here again, it's typically written, rather than having this factor of 2 at the front, we apply a factor of 1/2 on the other side. So this is going to be typically written as the sine of u times the sine of v equals 1/2 of, and there's this difference that we started with, the cosine of u minus v minus the cosine of u plus v. And those then form the two product to sum identities. Now, we realize that this isn't typically referred to as a sum, but the general name of this group is the product to sum identities. If you wanted to be particular about it, we could say that that's adding the opposite of this quantity. But ultimately, two cosines, whether they're being added or subtracted, produce either a product of two cosines or a product of two sine values. Now let's consider for a minute when both of these we started with two cosine values, one a sum and one a difference. Let's look at what happens when we start with sine values. So in this case, we're going to look at the sine of the quantity u plus v, plus the sine of the quantity u minus v. And we want to expand both of those using those sine sum formulas that we have. So the sine sum says take the sine of the first angle times the cosine of the second, sine u, cosine v. Keep the sine the same, so this is still a sum. Sine of the second angle times the cosine of the first. Now we're going to add to that the quantities that we get from this sine difference, in which case we get the sine of u times the cosine of v minus the sine of v times the cosine of u. Squeeze that in there. And here again, we've got some terms that are going to cancel. We've got a positive sine v cosine u and a negative sine v cosine u. Noticing as well that the other two terms are like terms, sine u cosine v. So we combine those like terms, which produces 2 times the sine of u times the cosine of v. Now, in similar fashion, these are typically written as well with that 2 expressed as a 1/2 on the other side of the identity. So here we have the sine of u times the cosine of v is equal to 1/2 of this sum that we originally started with. The sine of the quantity u plus v plus the sine of the quantity u minus v. And that forms the third of our 4 product to sum identities. The last one, as you can probably assume, is going to be formed by taking the difference of these two sine quantities. So let's look at that last one together. In which case, we're going to start with the sine of the quantity u plus v and subtract from that the sine of the quantity u minus v. Now we know, as from our experience up above, that what that's going to do is change the signs, positive and negative signs, in these two last terms. So in which case our expansion of this first quantity stays the same, sine u cosine v plus sine v cosine u. And now we're going to subtract the sine of u cosine v and add, changing the symbol here, the sine of v times the cosine of u. If you needed to, you could write that quantity in a set of parentheses and then distribute the negative if that was more helpful, but ultimately it produces the same end result. So in this case, the two terms that are going to cancel each other out are this sine u cosine v quantity, and what we're left with remaining is 2 times the sine of v times the cosine of u. So our final identity for the product to sum formula says the sine of v times the cosine of u is equal to 1/2 of this quantity that we began with, the sine of u plus v minus the sine of the quantity u minus v. And that is the development or derivation of the product to sum formulas. In the next video, we're going to look at the last set of identities that we'll have, which are the sum to product identities. See you soon.